Hello there, everybody. Good afternoon. Today's lesson is about related rates, um, concept that you may or may not remember from last year. But here we've got a situation where we've got a hot air balloon, and it says it starts out 100 feet from an observer on the ground. So we got a person on the ground, we got a hot air balloon on the ground, 100 feet apart. And it says the hot air balloon travels straight up at 10 feet per second. So it's going straight up. Okay. So how fast is the angle between the person's line of sight and the ground increasing when that angle is pi over 4 radians? So there's a lot of stuff going on in this problem. We got a hot air balloon that's moving. We got a person that's standing still. We got a whole bunch of variables to keep track of and figure stuff out about. It's really going to help you on these problems to draw a picture. Right, so I want to really encourage you to do that on your assignment tonight and as you practice these, to draw a picture. So let's draw a little picture here. Let's see, there's the ground. We got this person on the ground. We've got a hot air balloon that starts 100 feet away. Starts out 100 feet and it's going straight up. That distance isn't gonna change. I'm gonna draw it up here a little ways. Because since we know it is going up, so there is our hot air balloon. Let's put a person in there. Whee! There we go. And let's see. So we're talking about it says something about a person's line of sight. How fast is the angle between the person's line of sight and the ground? So the person's line of sight to the hot air balloon is like that. And the angle between that line of sight and the ground is something that's changing as this this hot air balloon goes up. See, it's going up. We're told it's going up at 10 feet per second, so we'll put that in there. This quantity right here, this angle is changing, so let's give that a variable. Let's call that theta. You can call it anything you want. I'm going to call it theta. This angle, as long as the ground level, should be 90. I suppose that's a safe assumption. We've got the 100 in there already. Another thing that's changing as the hot air balloon goes up is its height. Let's see, what do I want to call that? Let's call the height h, just for the heck of it, h for height. And this distance here is also changing as the hot air balloon goes up. So let's call that distance d. So now we've got all our variables kind of defined here. We've already started on the second step here, defining the variables. We didn't do it in words, but if you put it in the picture, we know what those variables represent. So that's fine. There are some other things that were given here. We're told about this instant in time, or we're asked about this instant in time where this angle is pi over 4. So let's write that in there. This quantity right here is the rate of change of the height with respect to time, because we got seconds down here. So let's write dh dt is 10. Now it is going up, this height is increasing, so we are going to make that positive. Let's put feet per second in there too, just to be thorough. Have some units. Let's see, what else are we given? I think that's about it, but what are we looking for? It says, how fast is the angle between the person's line of sight and the ground increasing? How fast is the angle increasing? That's d theta dt. That is what we're looking for. The rate of change of the angle. Okay, so one thing I notice here is that we aren't given any information or asked anything about this variable d right here. We know a little bit about the height, or at least the rate of change of the height is 10. We know we're asked about this instant in time when theta is pi over 4. We're asked about the rate of change of theta. We're not given anything or asked anything about d, so that's probably going to be a variable that we do not use. The last part of the second step is to write an equation that relates the variables in the problem or in the diagram together. So we need an equation that relates theta and h. It might involve the 10 or the 100. It might even involve d if you really wanted to. And actually involving d is going to be a problem, again, because we don't have any information about d at all. We don't know anything about it. We don't know how it changes. We don't know what it is when theta is pi over 4. We just don't know much about it. So let's try to write an equation that relates the variables that we do know about. That's theta and h. Now if you remember your right triangle trig, theta, this is the opposite side, this is the adjacent side. So we know that the tangent of theta, because tangent is opposite over adjacent, is h over 100. And that is an equation that does relate theta and h, the two variables that we have information about and that we're interested in. So let's see if that gets us somewhere. If it doesn't, we'll come back and we'll try another equation. You might think, hey, Pythagorean theorem would work, right? H squared plus 100 squared equals d squared. Now, why didn't I write that one down first? Well, first of all, it didn't involve theta. We have to have theta in that problem because we're asked about how theta changes. So any equation we write has to have theta in it. So that's the reason why I didn't write that one at first. And you would see eventually if you tried to go to step 3 with this equation that it wouldn't work. So here's our equation. Tangent of theta equals h over 100. So next step is to take that equation, differentiate it with respect to time. Remember, these are rates of change with respect to time. We're over seconds here. So we're taking d dt of both sides. Okay. Well, the derivative of of tangent is secant squared theta. Now we're deriving with respect to time, not theta, so we've got to have a d theta dt in here. It's kind of a chain piece. It's the chain rule. The derivative of h over 100 is 1/100th. Again, we're deriving with respect to time, not with respect to h, so we do have to have that chain piece out here, dh dt. So now we've derived. Now it's time to plug stuff in and solve for what we're looking for. We're interested in this instant in time when theta is pi over 4. So let's plug in pi over 4 for theta. D theta dt is what we're looking for. So we'll write that in there. 1 over 100 doesn't change. dh dt. Well, we know that's 10. So let's plug in 10 for dh dt. Okay. So now we've got an equation with just the only non-constant in there is dh dt. We can solve for it. So, or d theta dt. So we can solve for it. So d theta dt, let's see, we've got, this will simplify to 1/10. We can divide both sides by secant squared of pi over 4, whatever the heck that is. Let's see, what's secant of pi over 4? Cosine of pi over 4 is root 2 over 2. So the secant is going to be 2 over root 2, which is just root 2. And then we're squaring that. That makes it 2. So we got 1/20th. Because that's 2 and that's 10, 1/20th. Now, what are the units for the d theta dt? Well, our theta up here was in radians, and our time units were seconds. So our answer here is going to be in radians per second. And that is d theta dt, which is what we were looking for. Okay. So step 1, draw a picture. Help you picture the problem. Put in any variables that there are, anything that's changing in the problem. Give it a variable. If anything is constant, like the 100 was, put in that number. And that can help you define what your variables are too. The next step, define the variables, which if you've done a good job with the picture, you'd have already done. And then write down what you know. Right? We knew we were interested in a time when theta was pi over 4. We knew that the hot air balloon was rising at 10 feet per second. That's dh dt. We wanted to know d theta dt, so we wrote that down too. And then you have to write an equation that relates all that stuff together. And we figured out that this was a better one because we wanted to know about theta, so we had to have theta in here. We didn't know anything about d, so we didn't use an equation with d in it. And so that's the equation we wrote. Tangent theta is h over 11. And that, or h over 100, that equation will depend on the situation. I would not have been able to write that equation without drawing the picture. So draw the picture. Yes, Danny Arndt, draw the picture. Yes, you have to draw the picture. Draw the picture. Next step, after you've got that equation written, you just got to differentiate and plug stuff in that you know and solve for what you're looking for. Okay. Your assignment is on page 251, number 8, 9, 11, 13, and 16. There you go. Hope this rings a bell. If not, do your best, work together, see if you guys can figure it out, and I will see you tomorrow. Bye.